This work is collaborated with Si-Yu Huang and my advisor, Hahn-Ming Lee. Our work intends to solve a problem in space-flight surface network detection. We propose a spatial snapshot mechanism for delay-free detection. Because currently some detection mechanism proposed by others previous work will exist some delay-free detection problem. Okay, so in this topic, study we want to get. This is today's presentation outline. First, I want to introduce these issues for you, and then we propose the spatial snapshot black box detection system, and the experiment to verify validation our work, and then the conclusions. And the introduction includes several parts. First, what is Fast-flux DNS attacks, and some related work for the decision method, and our motivation, challenge, and proposed approaches concept. And let me change the ordering for the introduction. First, the bottom is the normal host, and sometimes they query some domain names, query request to the normal domain name server. And the normal domain name server let the normal host know that maybe you can ask another domain name server. And actually, unfortunately, this server is compromised by botnet. And this server will postpone this message to the mothership, and the mothership give the malicious URLs and domain names to the this domain name server says, oh, you can tell the normal user that he can go that domain name. And after that, this normal host and go to another domain name server address, and this address is also hosted, compromised by the mothership. And the mothership they will ask the mothership that, oh, what content I need to give this normal host, and they give a scam website or phishing, or sometimes this website may exist some drive-by downloads exploit code. And then, unfortunately, this normal host has infected. So after we check the domain names logs, we can see that this domain names query has different parts. The first part we identify that we given the consumers roles, because they may respond a list of IP addresses. And also we can identify this part is providers. These two terms we will use later. And okay, so actually in Fast-flux service it exists some problem. The first one is characteristics. The first one is they exploit normal DNS techniques. Actually, they use content distributed CDN service infrastructures, and mostly used by botnet. And then perform ever-changing network of embedded hosts acting as a proxy. For example, before TTL time in DNS record, you can see this list of IP addresses correspond to this domain name. However, after the TTL, in the Fast-flux service, this IP address was changed significantly. So botnet try to use this kind of technique to evade their true source. Okay, some related work focus on these issues. They try to use temporal characteristics proposed in NDS 2008. They try to for before example, they try to extract the features that in the previous TTL time and the current TTL time, how many DNS record has been changed. Okay, I think this is a straightforward solution. However, that it is a limitation is that we need wait a long TTL time for extract these features and depend on different TTL time. And also follow this work. Another work has proposed to enhance this method. They try to give us some constraint, and they shorten the delay detection time. However, it still exists 1 to 3 hours delay detection time for extracting the features. Okay, so our motivation is that we want to elevate the delay detection time, also maintain acceptable accuracy performance. Okay, so we want to not wait long TTL time for extracting the features. Could we change another way to extract some other meaningful features? And because if we wait this long TTL time, it will cause more damage within the delay time. For example, binary propagation and online scans. Okay, for example, you might need wait 60 or 150 minutes. Another story is from because we have a meeting with the Trend Micro. They say they want to provide a network service below 15 minutes to respond to the client user that this address is normal or benign. So if we use this kind of method, it's impractical. Okay, our motivation is we want to capture the spatial snapshot mechanism. Actually, according to our observation, we can find that in Google.com, their provider and the consumer's distance is quite close. And different things in Fast-flux service network, their A record and S record IP address is distributed. So we can use our eyes to distinguish these two things. However, we want to make it automatically. So we need to develop some mechanism to distinguish these two things. However, it's not a straightforward because it still exists some challenges. The first one is normal-like behavior. We need to distinguish the normal behavior and the Fast-flux service network. For example, we encounter the content distribution network, CDN service. Also, actually, because we learn from data, so we encounter another problem is unbalanced data problem. Because most of the data is normal, rare of them are abnormal. And after that, we encounter the pattern variance problem in the spatial snapshot. Okay. Our concept is we propose two measures. The first measure is to estimate spatial uniform distribution. We try to capture the different time zones entropies measures to find whether this distribution is uniform or non-uniform. Another thing is we want to measure the spatial search distance. So we measure the NS and the A1, A2, A3 distance. And to know this distance is have a large distance or low distance. I roughly let you know our contributions. The first thing is we propose a delay-free detection mechanism. It replaces original temporal characteristics with spatial snapshot mechanisms. Also, we provide a novel spatial mechanism to identify FFSM because we propose these two measures. Actually, this work also uses techniques which name is Bayesian network. However, because this work focuses much more things in security, so we do not mention this a lot. After that, we also publish a data set. In UCI, it's a data mining data set repository. Also, you can get it from the author site. Okay, now I introduce our systems. Spatial snapshot Fast-flux detection system. It includes three parts. The first one I will let you know the system architecture, and then we detail the two measures. We get the data from the DNS packet monitoring, and this is a DNS record. And then we extract the IP from that record, and then we do the mapping from the spatial coordinate database. It is the geographic coordinate database from the open project. After that, we measure the spatial uniform distributions degrees and the spatial service relation degrees. And then finally, we put into the Bayesian network detector. Example is like this. For example, we query a domain name neuro.csre.ntsd.edu.tw. And it will respond this IP address and the additional section IP address. And this we regard as a consumer, and we regard it as a provider. After that, we query to the spatial coordinate database.